IID. Okay, how you distributed then?
So using a K-fold cross-validation technique, K-fold system.
Then for distribution, what function you must have used some functions. It is
Yes,
not...
sir. For distribution, only I have used the K-fold technique for distributing them among the clients.
Okay, thank you.
Thank you, sir.
So I have few queries. So you have done the simulation in real-time data or static data?
So it is static data. It's not real.
Okay. So in pre-processing stage, you
Yes,
have
sir.
used median filter.
Yes, sir.
What is the objective of using the median filter?
So it is to improve the contrast of the images.
Okay. So how you ensure that median filter solve all type of noises? Because whenever the image being captured by any of the device,
Yes,
right?
sir.
So the noise are not similar type. These are not homogeneous noises. They may be salt and pepper, Gaussian noise, Erlang noise, different type of noises are there. So how you ensure that median filter will solve your issues? Because there must be an adaptive filter, because noise quality, noise type may vary with respect to different type of capturing devices and images.
Yes.
So I don't think I don't agree with this proposal. First thing. Second question, how ensure security and data privacy in this particular model? You have mentioned in introduction and many places, but there is no significant result we are getting. How you are maintaining the data security and privacy?
Okay, sir. So for the data security thing, the features that I have extracted were using the first I have extracted the features of Shift and ORB. Then I have reduced it using the PCA technique to 512 units.
Okay.
Okay, that thing doesn't if I get that features, then I will not be getting the exact image which preserves the privacy in that case. For further thing, I have also used the autoencoder model for the fusion dataset, which is reduced to again the 512 units after the fusion. So that also encodes the feature set. So that also helps in encoding, ensuring the privacy.
These methods are existing methods and these have certain limitations.
Yes.
So how we ensure that it is giving more security and privacy to our data, health related data, right? So autoencoder, some of the methodologies are there in the programming language itself that can convert.
Yes.
But how we ensure that we are preserving our data properly? Okay, thank you.
Okay, thank you, sir.
Any queries from the audience? Okay.
মানে আপনি বিয়ে করতে গেছেন
না না জাস্ট তো স্লাইডটা একটু ওপেন করে তো জোর প্রেস করলে নেক্সট
Okay. Good morning, everyone present over here. Presenting my paper, which belongs to the domain of face mask detection. Title of the paper entitles to be High Accuracy Face Mask Detection in Nuclear Power Environments Using Ensemble Learning and XGBoost. So this is the agenda for today's paper presentation. So beginning with the face mask detection process, be it any sector, be it, it may be a nuclear power sector or hospitalization sector or in the general market sector, the provision of inculcating people to prevent their in harmful particles and unwanted particles from the environment to enter into the respiratory system. The face masks provide a barrier, further ensuring security and personal protective equipment, including the credibility of the whole process. So this presentation proposes an enhanced face mask detection system using advanced technologies to improve the further accuracy, enhanced efficiency, and compliance with the safety protocols. But concerned with this particular, I have been doing only the for focusing on the accuracy portion. So the first set of authors have used CNN and mobile net B2 and achieved an accuracy of about 96.3%. The authors have taken the dataset from the public repository, which included of about 2,000 of datasets, including masked and unmasked uh, data. Along with it, they tried to make a ensemble of these two models, and further they yielded the accuracy of about 96.3%. The second set of authors tried to elevate the risk of the amalgamation and propagation of the harmful bacteria from the environment with the help of certain deep learning techniques, which included like stacking technology along with CNN and Inception V3, and further they achieved an accuracy of about 95.2%. The third set of authors proposed a YOLO-based deep learning model for real-time face mask detection via drone surveillance in public spaces. The methodology which they inculcated into their model is YOLO along with CNN, further combining with Darknet 53, and further yielding an accuracy of about 92.2%. The fourth set of authors implemented the detection system by combining SVM and HAR cascade in the OpenCV along with certain deep learning techniques such as CNN along with DenseNet 51 and further yielded an accuracy of about 95.8%. So the motivation for my work was in the first concern was to improve the safety concerns, but this is the work doesn't consolidates this part, but I have tried to increase the accuracies of the model that can be further deployed in any system, or that will enhance the overall accuracy process of the whole model. Further, I've developed a detection system to ensure strict compliance with safety protocols. The dataset consists of around a total of 7,553, combining of both masked and unmasked data of the persons, and the pre-processing techniques combined for this is image resizing, normalization, data augmentation. First, I tried to managed with different type of angle rotation, and further tried to fix that 90 degree was the appropriate angle rotation for the data sets. Further, shift height shift range and for horizontal flip along with vertical flip, also shear transformation was inculcated. So the thereafter the whole data set previously was split into 80 to 20% of ratio. The each model combined was base CNN, Inception V3, DenseNet 121, and along with EfficientNet B2. Each model learns unique feature representations from the dataset. Then further, the weighted ensemble strategy was inculcated into the whole model. For that, XGBoost system, XGBoost process was being inculcated at the final stage to handle the refinement of the layers along with correct misclassification and enhance the final decision making. It further helped reducing classification errors and fine-tuned the final predictions. The performance for to ensure whether the classifications are carried out correctly or not were accuracy, precision, precall, MCC, and kappa score was inculcated. So the results came out to be around 98.1% before the integration of XGBoost model into the whole process. After the integration, the further accuracy increased to about 99.32%. So concluding with the work, the system is highly reliable, scalable, and yet the data more diverse amount of data set need to be inculcated so that it will be more reliable in the near future. So the future work inculcates that transfer learning along with federated learning to be applied so that the security, which is the main concern of this work, will be enhanced in the near future. So these are some of the references being taken for the work. So thank you. If anyone would like to give any suggestion or any questions.
Kindly go to the result section. Okay, you have calculated the efficiency in terms of accuracy, is it?
Yes, sir.
So how you ensure the security?
So actually, I haven't considered that portion into this work because I'm working on it currently. So
No, the main objective of the work is face mask. Using
Yes,
the
sir.
face mask for two purposes. For
one is security, and another one
security
is
and
enhancing
another
the
is,
accuracy of the whole
yes,
model.
respiration problem.
Yes, sir.
Right.
Yes, sir.
So which part you have proved in this
Sir, I
particular
have
demonstration?
enhanced the accuracy portion for this work.
So for which accuracy? For security purposes or for respiration issues?
Sir, for security respiration purposes.
Okay. So I have one query. So you have obtained 99.32
Yes, sir.
accuracy.
Yes, sir. So this is because
So
of
how you have handled the overfitting of your data set?
so to like reduce the overfitting, I had previously done the at the pre-processing stage. I have inculcated the data
Which
augmentation.
method, my question, which method you have used to avoid overfitting?
So to reduce this particular issue, as I'm saying that augmentation was being like performed from the start, inculcating around 4 types of angle degree was being inculcated so that it will enhance the overall diversity of the data set. That in turn will reduce
I'm
the
asking about the
overfitting.
methods only.
Yes, sir. At the pre-processing stage, data augmentation was done.
I'm
So
not asking augmentation. I'm asking how you have handled over because you have obtained 99.32 accuracy. Could you to observe?
yes,
And you
sir.
don't have confusion matrix also. From that we can able to extract, but you don't have. It should be.
Yes, sir. I totally get it, sir.
Confusion
Actually,
matrix should be there.
those are in the paper, so I haven't.
And how you ensure the scalability?
Sir, that I haven't figured
Have
it
you
out yet.
tested any experimentation by using some of the mask?
Sorry, sir.
Have you tested this in real life?
No, sir, not yet,
So
sir.
how you ensure the scalability of your model?
Sir, that I haven't like figured it out yet because I will be means currently I'm working on federated
Whatever
learning.
you are presenting, you should be ensured about this because scalability you are mentioning, but it is not ensured. in your
Yes, sir,
model.
totally get it, sir.
Okay,
But the
you should
thing
be
is,
taken care of these things.
my main focus was on enhancing accuracy. So that I have done, and rest two objectives will be done in the near future.
Okay.
Anuradha, if you are able to achieve 99.32% of accuracy,
Yes, sir.
then what further enhancement you will be doing, user? So it's a very high good percentage of accuracy.
Yes,
So
sir, I
there is
totally
no
get it.
need of federated learning. Nothing is required. You said in future you will be applying the federated learning and all.
Yes, sir.
It's not required at all. If a
Um,
problem can be solved without using machine learning or deep learning technique also, so that is better. Conventional methods are better. It is not necessary that always you will be using for each and every problem you will be using deep learning, machine learning problems.
Okay, sir.
Solutions you will not be giving. You have already achieved 99.32%.
Yes, sir,
If
I
you are
get it.
saying.
But the thing of like, as sir asked, like how will be like ensuring security and how will be like scaling the whole model? Like how are you going to make the model more robust? So on that terms, I would like to experiment. So that's why I've been thinking of doing it with federated learning.
That means the respiration part is over. As
Uh,
per your result, the respiration part is over. You have achieved the means very good result you have achieved already.
yes, sir.
We are not going to enhance anything in the respiration part.
Currently not, sir, but after I like complete with the federated learning portion, I will be coming here again, and if I get it to do something else, I'll surely do it.
What do you think? If you apply the federated learning approach, this respiration accuracy will enhance further?
Sir, if it also enhances, but though I haven't like tried totally, but I'm not sure of it.
Okay. Okay, thank you.
Thank you.
Okay, any questions from audience, please? Okay, thank you.
Okay, sir.
Start. Good morning, respected professors and my fellow researchers. My name is Amit Kumar. My name is Amit Kumar Naik, and I'm from Gita Autonomous College. Me, along with my mentor and co-author, Professor Debasis Pradhan from CSAML department, have created this research paper on topic an extreme gradient boosting based automated software defect prediction model using dimensional reduction techniques.
এটাকে ART থেকে জোর দিয়ে প্রেস করে
আচ্ছা,
জাস্ট উঠে তলটা ট্রানজেন্ট নিচে
battery surge.
नाही बेटे काय झालं
Touch screen.
की जोर प्रेस करेंगे
Uh, Now these are the outline or topics of discussion. Introduction. Software testing process is a crucial part in software development. Generally, the errors made by developers gets fixed in latter stage of software development process, which increases the impact of defect since the product that they have created is already in the market being used by customers. So therefore, negative feedback is an oncoming. Now, to prevent these defects, these defects need to be predicted during early stages of development, which in turn helps in efficient utilization of the testing resources. Now, defect prediction involves classification of software models into defect prone and non-defect prone. It would be unnecessary to test the whole software model, instead just testing the defective portion. To develop an accurate software prediction model, it is essential to have high quality data that accurately reflects all the aspects and behavior of the software. Now, this data may include information like code complexity, runtime behavior, lines of code used, number of comments used, number of spaces used, variables used, etc. In this research work, our designed model PCA, which is used for feature reduction, and XGBoost plus RF, which is a combined hybrid ensemble learning technique, we have proposed. Now, this is the diagrammatic representation of what we are trying to achieve, which is ensure software quality, that is all the functionalities remain intact along with removal of defects. Identify and fix defects earlier. If we could identify and fix the errors during the development process, there wouldn't be so much hassle during the testing, and it would be outflowed and perfect at customer support. Improving customer satisfaction, which is a given. Compliance and standards, maintaining top standards and giving the customers what they have request. And risk management, which mitigates risks and enables continuous improvement. Now, the motivation behind this research work is to design a machine learning model that provides more accurate result in predicting if a software is defect prone or not. It helps to find undiscovered defects, such as which may be skipped out or mistaken by the developing member or skipped out by the testing software. This kind of defects can be predicted by our model. This work aims to reduce the impact of two major issues faced in defect prediction, like data imbalance. Creation of a software involves different kinds of modules. For example, a software with a login page, a software with a shop interface, a software with logout page. These may have multiple defects and higher dimensionality of datasets. This research work aims to reduce the features by using feature reduction technique, which is the PCA, with the aim to get more accurate results. To design a hybrid learning model which would predict the system with more accuracy and minimum errors. Now, the inspiration behind this paper is widely from Professor Wang, who developed a hybrid feature selection model using three different components which align with our research, that is random forest, PCA, and XGBoost. But his model involved individual classification or dimensionality reduction in his paper. And after 10-fold cross validation, he achieved an accuracy of 98.65%. Professor Qasim also proposed one distinct paper. This is the inspiration of datasets that we got from, which employs two distinct algorithms, namely MLP and CNN. According to their study, it was noted that the CNN algorithm demonstrated superior performance compared to an MLP, especially when KC1 dataset achieving 95.61%. These are some other notable researches which involved the rotation forest algorithm implementation along with J48 classifier, which gave us a 96 point, gave them a 96.4 percentage accuracy. Now this inspires us to create the hybrid model, which is the combination of XGBoost along with random forest. Now, some of the challenges that we have faced in the development phase are: we have recognized that most of the work is based on parametric software reliability models. These models are built with a lot of constraint and they're useful when the data is simple. As the data complexity grows, the data imbalance and overfitting issues overwhelm them. But in reality, defect prediction data is very chaotic. ML techniques have shown significant better performance with chaotic data as compared to traditional software reliability models. Many studies also predict defects based on projects or domains. They just classify some of the errors into one category. Every kind of error has a special kind of treatment to them. So it is necessary to keep an outlook for those special kinds of errors as well, which is handled by our PCA. Coming to the proposed methodology, firstly, the datasets are introduced, processed, and feature dimensionality reduction using PCA is done. Along with XGBoost and random forest integration, we get a performance evaluation, make a performance evaluation. Now, the datasets that we have gathered, they are NASA datasets, which are CM1, MC1, PC1, PC2, and MW1. And these datasets are actually the collection of all the defects that are being faced during the production of softwares like flight detection system of aircrafts, like element detection systems from a camera to the ground, like mission control systems, which is the MC1 dataset. These are real world applications, and these datasets are the congregate or aggregate that these softwares had in them. So the number of total samples, the healthy samples, defect samples, and the features based on which we are classifying them. That is the number of lines of code, number of spaces used, variables used. These are the features. Now, feature reduction in PCA is done through through correlating features into correlated principal components, preserving critical variance, along with discarding redundant data. Now, some software may have some specific kind of errors that occur when specific terms are met. Now, these may be easy to avoid due to high variance, not so much related to mistake in a code. So easy to mistake in a code, but this error may be shut down the system after 8 hours of working. These are very much unrelated. But these extreme variances may cause customer dissatisfaction. So PCA directly aids with understanding feature relationship and contributes to software defect prediction. Now, XGBoost. XGBoost is used to continuously create decision trees based upon the data sets and keep improving the model accuracy throughout the process. Now coming to the ensemble model, the XGBoost, it continuously creates decision trees, studies on the same old data set again and again, which causes a overfitting issue since it keeps using the same data set. And we integrated random forest to that. Now what random forest does, it takes a subset of from the main data set and only evaluates that part. Now it keeps taking subsets, and ultimately a number of decision trees are created by random forest. Finally, the predictions from all decision trees are aggregated together and then given an prediction. XGBoost has the flaw of overfitting. A random forest resolves that flaw by creating multiple decision trees from unknown dataset locations. Next. These are the evaluation parameters that has been considered by us, which is sensitivity, specificity, precision, F1 score, MCC. Now, after the application of our selected models, now without PCA, from the 5 datasets that we have considered, MC1 has performed significantly better with an accuracy of 98.65 with PCA, and without PCA it is 98.07%. Now this is the performance evaluation table. This is the comparison between different kinds of classifiers with our classifier, which seems to outperform others. This is the data with PCA. This was without PCA. This is the graphical representation of the previous tables. Now, we did a review of the other literatures proposed by Professor Pradhan, Professor Malik, and among them, our proposed model, that is PCA plus XGBoost RF ensemble, has outperformed. So, concluding the research, PCA plus XGBRF model is designed in our recent study to identify software defects. Now it outperformed with an accuracy of 98.65 with MC1 dataset. When MC1 dataset is applied to out of the 5 datasets, more research could explore hybrid models to enhance accuracy, balance complexity, and improve interpretability by integrating other optimization techniques and divert datasets. These are the references. Thank you.
Okay, go to the comparison table, result analysis. Okay, that's okay. No, next. Next. Go back. Next. Okay. So you have not used stacking classifier anywhere else?
No, sir.
But you have shown in
Bagging based.
yes?
It's a bagging based algorithm. RF.
Stacking classifier you have not shown.
No, sir.
But you have mentioned somewhere else. Stacking classifier with random forest. That method you have mentioned somewhere else. Why you have not make the comparison of that particular methodology?
Sir, it's in study yet. It isn't concluded yet. It is still in study. The results are not formed,
Results are not good.
concrete yet. We are still making
Okay.
improvements on that.
So you have how many data sets you have collected?
5 datasets. 5 datasets.
5 datasets. How many attributes of each dataset? Attributes?
Sir, ranges from 21 to 30 features within each dataset. So individual
You have
application
considered all the attributes, or you have reduced the attributes? How many-
reduction is applied.
Which methodology you have applied for attribute reduction?
Feature reduction, sir, PCA is used.
Okay. What are the undiscovered errors you are able to capture here from this data set?
Sir,
So that is what your aim is
yes, sir.
all about.
That was one of the aims.
Yes. What are the different on the means just from layman point of view, just tell me,
Yes, sir.
suppose there is one software, what are the different on this particular data set? What are the undiscovered error you have found?
Sir, in one of the datasets, that is MC1,
Mhm.
there was something called checking of comment lines. In the dataset itself, the other ML models that were proposed, they didn't like ignored the comment lines itself. Like the comments that were written in the coding language itself, the software, they ignored it completely. I mean, that is should not happen. It should take into consideration, even though it is not required, and even though it doesn't propose some
Can't it
functionality.
be
Along
detected
with
by
that,
using the normal software testing? In normal software testing, algorithm can also do the same things. What
Yes,
is the meaning of using such kind of means a method for this?
sir, there are other errors like there was CM1 dataset one.
Mhm.
After working for, there are some minor time adjustments that they say. After working for certain period of time, it would have a relapse, like restart the software again. After working, let's say 15 minutes, it would restart the software. And within that time frame, the data that is the software is meant to capture, it is lapsed, it is ignored completely. So our model, it recorrects that, it shows that default in the system,
Hmm.
basically.
So that means you are saying means using normal software testing techniques, I cannot do that.
They couldn't predict that. One of the flaws with Professor Mehta and Malik, it had one of the flaws. They couldn't do that, restarting, pointing out the restart thing.
Okay. All right. Thank you.
Thank you, sir.
Your next presenter, please.
Next, previous one.
Good morning. Good morning, everyone. I am Sachi Thora, going to present today's paper on intelligent system for corrosion detection. Hello, am I audible, sir? Good morning, everyone. This is SRG from Gunasika Plus 3 Science College, Keonjhar. Today, I am going to present the paper on intelligent system for corrosion detection and prediction system using deep learning. Starting with the introduction, Bridges are very critical components of modern infrastructures, providing essential connectivity for transportation and commerce. However, their exposure to environmental factors such as humidity, temperature, and fluctuations and pollutants often leads to corrosion, compromising the structural integrity and safety. Regular inspections and maintenance are essential for mitigating these effects, but traditional methods are often labor intensive, costly, and limited in their ability to provide the real time insights. This highlights the need for advanced systems capable for continuous monitoring and predictive maintenance, which shows the background about the critical infrastructures assets that require continuous monitoring to ensure the safety. Yes, sir. So this paper comprehensive.
Methodology discussion.
Sir. Yes, afterwards, after problem identification and methodologies. Yes. Sir, we have used wireless sensoring networks for detection by using deep learning process and clustering properties. Uh, So the proper methodology for an energy efficient wireless sensor network for corrosion detection and prediction of breezes, combining clustering techniques with hybrid deep learning processes, which will be good for energy consumption, scalability, and prediction accuracy, and for ensuring real-time monitoring and reliable decision making. This thing will we have different stimulation parameters where we have used 30 sensors and different kind of stimulation numbers like bridge length, width, node deployments, and different packaging size and base station locations. Here we have seen the performance matrices where the system is evaluated on energy efficiency, which defines the measuring total consumption for network cycle, access network lifetime with or without clustering method. Another one is the for the prediction accuracy, which evaluate the deep learning model performance using matrices such as mean absolute error and root mean squared errors. And latency, where we measure the time delay from data collection to prediction outputs. And also scalability, which shows the testing system ability to handle increased sensor density and bridge size. We have different data sets also, which shows deep learning model, which are designed to capture the key environmental and corrosion related parameters which are affecting the condition of different kind of bridges. The dataset also includes the time series data collected from sensor node deployed on the bridge, representing the both spatial and temporal variations. And we have given node IDs and stamped pad, and we have used 36,500 records, like sample testing records for validations. These are the recent node clustering bridges where we have taken different kind of cluster heads, and we have so next we have shown the corrosion rate where we are showing the